In this first video for Module 19, we consider Ice Age periods in the Earth's history. So what's the first thing that comes to mind when you think of an Ice Age? You probably think of a colder period in the Earth's climate history, but you might be surprised to know that Ice Age periods were also wetter periods of time with a lot more precipitation, principally snow falling. Some of the credit for Ice Age periods in Earth's history go to the guy in this slide, Luis Agassiz, who is a geologist who lived between 1807 and 1873. And he came up with the idea that the Earth experienced these colder, wetter periods. And we'll look at those specific periods in just a minute. But before we do, let's talk about two characteristics of Ice Age periods. The first one is that large areas of the Earth were covered with glacial ice. That makes sense. And a second that sometimes we may not think about is because a lot more of the Earth's water was locked up in snow and ice, sea levels were lower in all ocean areas. So modern explanations for glacial periods, there are many, and no one is exactly sure what the most important contributors are to Ice Age periods. But let's take a look at some of the contemporary ideas for factors that may influence Ice Age periods. One of those is Earth's tilt or orbit. So we know that today the Earth's tilt, that is a line perpendicular to the plane of the ecliptic, that invisible plane that the Earth rides on as it goes around the sun, is about 23.5 degrees, but it hasn't always been 23.5 degrees. It may have varied a little bit between 22 and 24 degrees. Second explanation or possible factor, variation in solar output. So the sun may put out more energy or less energy over periods of time. A third is the composition of the atmosphere, especially carbon dioxide and methane. So we know those gases tend to absorb long-wave radiation. So where you have more carbon dioxide and methane, you're capturing and retaining more energy. A fourth is volcanic activity, especially the eruption of supervolcanoes like the one that exists where Yellowstone National Park is today. And then finally, crustal plate movement. So the geologists and glaciologists suggest that the Earth has experienced 5 Ice Age periods, and we'll look briefly at them. So let's kind of walk through these 5 periods and just a couple of characteristics about them, and maybe a little bit about what the Earth might have looked like during these different periods of time. So the oldest one, the Huronian glaciation, scientists believe that took place between 2.7 and 2.3 billion years ago. And as I note on the slide, a lull in volcanic activity, reduction in greenhouse gases. So no less greenhouse gas in the atmosphere, more chance that the Earth's atmosphere will cool down. Cryogenic period, snowball Earth, ended by carbon dioxide in the atmosphere from volcanic eruptions. Then the Andean Saharan, a little bit more recently, but one of the coldest times in the last 600 million years of Earth history. The Carboniferous period, extensive polar ice caps, low carbon dioxide levels worldwide. And the most recent one, the one we're really going to focus on here in the next a few minutes and on into the next couple of videos, the Pleistocene, from 3 million years ago to roughly about 10,000 years ago. And during the Pleistocene, about 1/3 of the Earth's land surface was covered by ice. Remember that statistic, 1/3 of the Earth's land surface, not the whole Earth, the land surface. So I created this graph so you could sort of visualize the temperature change that may have happened in these various Ice Age periods. The line along the bottom isn't really a constant scale. I've sort of varied it a little bit. And this is time in millions of years ago. But you can see these Ice Age periods and how much the temperature varied. So these are sort of average global temperatures, so the temperatures can be much colder or much warmer. These are average temperatures, and you can see these different Ice Age periods. And the most recent one, the Pleistocene, shown right here with that blue line starting to tick up a little bit as we approach the current temperatures today. So I mentioned during the Pleistocene, about 1/3 of the Earth's land surface was covered by snow and ice. And in fact, every continent had snow and ice on it during the Pleistocene. There were 2 big ice sheets that covered North America and Europe. The The North American one was called the Laurentide ice sheet. We're going to talk about that one a lot. And the other one I'll mention just a little bit less about is the Scandinavian ice sheet that covered Europe. There were other places where ice was extensive. There were glaciers even in Australia, even in southern Africa, especially in the Andes and the southern part of South America and in Asia. Just to give you a feel of how extensive Pleistocene glaciation was in Antarctica, this view right here is to sort of show you how big Antarctica was 10,000 years ago as the Pleistocene was starting to dissipate. So the continent was a whole lot bigger in the sense of all of the snow and ice. And here is the current configuration of Antarctica. And looking at the Scandinavian ice sheet, 21,000 years ago, 21,500 years ago, ice sheet covering the Scandinavian countries and much of Northern Europe. And as the ice begins to recede and dissipate, 10,000 years ago. So you get some idea. But this ice sheet was perhaps 2.5 million square miles at a thickness up to nearly 10,000 feet. And the Laurentide ice sheet, again, is the one we're going to focus on the most. Now, one misconception about where the snowfall or fell that sort of fueled this ice sheet, most of it fell over Hudson Bay in Canada. That was the focus. That's a location that's near the subpolar low, so lots and lots of snowfall over Hudson Bay. So not over the North Pole. And that's a misconception that the most of the snowfall took place there and spread out in every direction. It actually took place much farther south over Hudson Bay, Canada, and spread out in every direction, including poleward. And here's another view right here. Hudson Bay is sort of in the middle of this mass right here. Now, one thing to note is that Pleistocene glaciation never reached Oklahoma. So if you're considering what effect the Pleistocene or any of these ice age periods had on Oklahoma, it was pretty minimal, at least the Pleistocene, which corresponds to the current configuration of continents. But that doesn't mean that the Pleistocene didn't affect Oklahoma. It certainly affected Oklahoma in indirect ways, and we'll look at some of those. One question you might have is, how thick was the Laurentide ice sheet? Well, pretty thick. I like this picture. It's a contemporary photo of Greenland, but it kind of helps you to visualize what the ice sheet covering most of North America may have appeared 10,000 years ago. You know, little areas of land that sort of stick up a little bit above the ice sheet. And I created this graphic so you can sort of visualize the thickness of the Laurentine ice sheet. So if 2,000 feet is represented by this black line, and I added the woolly mammoth over here on the upper right, that would be here's sort of equivalent buildings in terms of, to give you some feel for scale. The Empire State Building at 1,250 feet, the Chrysler Building in Chicago 925 feet, and the Statue of Liberty in New York City 310 feet. So just a comparison of how thick the Laurentide ice sheet was, just nearly half a mile thick. Here's a couple other buildings. We'll throw on there the World Trade Center 1 and the Sears Tower. Another image of the thickness of the Laurentine ice sheet as it would have occurred over New York City. Of course, these buildings weren't there at the time. This was a long time ago that the Laurentide ice sheet existed, but it's sort of, you kind of get a feel for how thick the ice sheet would have been even just over the city of New York, which is near the coastline. So it's pretty thick. Another place that was affected by glaciation was the Pacific Northwest, the Puget Sound glaciation. Here we see Seattle and Olympia, Washington, and the whole Puget Sound area of Washington State and on up into Canada, Victoria Island up in Canada. And here's a view during the Pleistocene, and then, of course, how Puget Sound appears today with these various inlets and things like that. So during the Pleistocene, this Fraser glaciation was pretty extensive too. Let's talk a little bit about some indirect effects of Pleistocene glaciation. So these are things that aren't necessarily tied to snow and ice covering the place where you are, but there are a couple things that I wanted to mention. One are the periglacial processes. These are areas not covered by glacial ice, as I say in the caption, but subject to severe freezing and thawing, such as seasonally frozen ground. That's ground that freezes in the wintertime, and then permafrost, that's ground that stays frozen all the time. So here's a view of some permafrost here. You can see the white, some of the soil here has been disrupted under this forest, and you can see the permafrost, that's permanently frozen ground. Pattern ground is something caused by this freeze-thaw action that disrupts the surface. It's a kind of an unusual phenomenon. So you have these surface pebbles that are picked up, set back down, picked up, set back down, and over time they begin to sort of organize themselves into patterned ground, forming these really strange sort of geometric shapes, like what you're seeing in the photograph to the left. Another thing that's pretty odd is where water that's trapped underground, kind of like an underground lake, freezes, and we know a property of water, when water freezes, it expands, and it forms this thing called a pingo, which is just pop up, this giant thing exploding on the surface, called a pingo. Pretty unusual. Sea level change is another. So sea levels are going typically during a glacial period, sea levels are going down, and then following the glacial period, as you come out of the glacial period, sea levels are rising as some of that snow and ice melts. And in fact, here's a sort of a view of the Earth that the way it might have appeared during the Pleistocene, with sea levels about 65 meters lower than they are today. And look at a couple things. Look how sort of thick and sort of bulky looking Florida is. It looks like Cuba and the Bahamas and some of these other islands are sort of all attached. We see United Kingdom connected to the rest of Europe. So some pretty odd things on this map. Because sea levels are so much higher, and we see Alaska is connected through the land bridge to Asia. Well, we can go ahead and lower those sea levels, get them back to normal height. So this is sort of current sea level, and the continental shelf that exists here represents the extent of land that might have been there during the Pleistocene. And then if we were to melt the glaciers that are over Greenland and Antarctica, the two remaining continental ice sheets, here we might see something that looks like this. We might say goodbye to Florida and a lot of the UK and a lot of low-lying areas on the East Coast, including much of the state of Louisiana. We'd have a big inland sea that would flood into the Amazon. Parts of North Africa would disappear. Parts of Europe and Asia would disappear. So kind of an unusual thing if sea levels were to rise. So it's a little bit of a concern. Here's that Bering land bridge that existed during the Pleistocene, where Alaska was connected to Siberia in what is today Russia. And the U.S. East Coast during the height of the Pleistocene, so 20,000 years ago. Sea levels 400 feet below where they are today. So the coastline would have stuck way out. So we have a lot of additional land here. New York City would have been pretty far inland. Philadelphia would have been pretty far inland. Same with Baltimore. So this is if sea levels were 400 feet lower than they are today. And if we had a 17-foot rise, that would be pretty devastating to the East Coast. Some of New York, Long Island would disappear. Manhattan would be affected. Philadelphia would be partly submerged. Baltimore partly submerged. New York City partly submerged. And then if we had a 170-foot rise, wow, big changes. So just some examples. If the ice sheet melted completely, we might be headed towards a scenario like this. It's not happening. It's not something we should really be worried about happening anytime soon, but it's just something we need to be aware of. Just to show you, this canyon called the Hudson Shelf Valley was a river valley during the Pleistocene. So the continental shelf came all the way out to the edge of this thing, this yellow line. So this was a terrestrial river valley. And when the much of the glacial ice melted and the sea levels rose, this thing was flooded out. So it's now an underwater, under the ocean inlet. And we can kind of see here's present day comparing 15,000 years ago, and there's that inlet, kind of viewed from an oblique view here in that present day, that bottom diagram. Once again, Florida, how it might have appeared 20,000 years ago, 400 with sea levels 400 feet below where they are today, and Florida today, or not, I'm sorry, not today, if we had a 17-foot sea level rise. So we could say goodbye to Miami, we could say goodbye to much of Jacksonville, New Orleans would be completely underwater, and a lot of Florida would disappear. Florida is not a very high elevation state. It really has a very low average elevation. And this is Florida. If we had a 170-foot sea level rise, it would just almost completely disappear. There'd be some islands that would be left. That would be about it. Something else that we can tie to Pleistocene glaciation is crustal depression. So we know that during ice age periods, when snow and ice builds up, all the weight of that snow and ice will compress the ground, push it down, compress the crust in some ways. And then just like as you get up off your bed after you put your shoes on in the morning, your bed kind of springs back. Well, the land does that too. it kind of springs back, and it's doing that in some places. I'll show you some examples so you can see where the land is actually rising. It's doing so in Coates Island coastline in Hudson Bay. So these look like they're former shorelines, and they are, as the land is actually rising. So this was the place here, Hudson Bay, that was the focus of where snow fell during the Pleistocene. So a lot of it really fell in this area in the subpolar low. So this area is rising. So are the Swiss Alps. They're getting a little bit taller every year, just imperceptibly taller. You really have to have a careful way of measuring, but they are growing in altitude every year because of the removal of all that weight as we come out of the Pleistocene. Much of Finland was a former seabed or archipelago and is now above ground. So sea levels have risen to help sort of create Finland. So in this view on the left, you see the blue areas are water, and this area on the right here is a more modern map of Finland. And here's Finland doesn't have very many tall mountains, but here's a view of one of the taller places in Finland, and try to imagine sea levels as they were higher at some time in the past. Finally, pluvial developments. These are features associated with glacial meltwater. So if you can imagine all that snow and ice when it melted, as conditions started to warm up and we came out of the last ice age, that water had to go someplace, and it did. So we had paleo lakes. These are lakes that existed in the past, and that's the definition of a paleo lake. So let me show you some examples. Some of these paleo lakes you've heard of. This one you probably haven't. This is Lake Agassiz, named after the famous geologist who came up with the concept for, or the idea that we experienced ice age periods. This lake was enormous. I mean, it was way bigger than the Great Lakes like Superior in Michigan. It would just be a massive lake, biggest lake on the planet if it still existed. And we see some evidence of this lake by some marine life that we can find, some fossil evidence that tells us that there was a lake here at one time. The lake is gone now because that glacial meltwater has dissipated. Maybe there wasn't enough water flowing into the lake to sustain it. But this is a paleo lake. Another paleo lake was a lake that covered much of central Wisconsin. These are probably things that were islands here in the middle of this lake, and I put a big blue blob in the middle of Wisconsin to sort of show you where Glacial Lake, Wisconsin was located. It wasn't real deep, but it had a depth that reached 150 feet in some places. Another paleo lake, and there was a recent Star Wars movie that was filmed here, is this lake in the Bolivian Altiplano, which means the high plains, during the last glaciation. And this particular lake is actually, or would have been, attached to Lake Titicaca, which is right on the Bolivian-Peruvian border, and that's what I'm showing in this upper picture. That's Lake Titicaca, and I'm showing it here as well, just so you can see. But this area outlined in light blue that stretches between Peru, Bolivia, Chile, and almost down into Argentina, this would have been this massive paleo lake, meltwater lake that existed down in South America at the end of the Pleistocene. So most of the lake's gone. Lake Titicaca, a few other lakes are left behind. And you see all the salt here on the surface, but this is where they filmed that couple of scenes from that Star Wars movie. I've got the little animation running here. Okay, I want to talk about another really interesting paleo lake located in the U.S., northern U.S., and this is Glacial Lake Missoula. And Glacial Lake Missoula, to show you where it was, it covered a portion of western Montana. So here's where Montana is today. And Glacial Lake Missoula was created by an ice dam, literally a place where the ice sheet and ice blocked a valley, and water built up behind that blockage and just filled this area of western Montana, what's today western Montana, making this massive lake. So at one point, this ice dam failed. So something happened when the conditions started warming up. The ice dam failed. Water started just flowing down in every direction following the blue lines that you see right here and flooded this area of green and made it all the way to the Pacific Ocean. An enormous flood happened 16,000 years ago. So this is the demise of Lake Missoula as it fails, this giant flood as water rushed downslope. And this is what it might have looked like, the Ice Age floodwaters through Lower Grand Coulee, a place you can visit today, and you can see evidence of this. So flood waters ran through this area with a force equal to 60 Amazon rivers, the flow of a current Amazon river 60 times. Car-sized boulders embedded in the rock, in the ice, floating 500 or more miles. It was pretty big. And here's some evidence. There was a giant waterfall here at Lower Grand Coulee. This river, for a time, had a discharge. Remember what a discharge is, the amount of water that flows past a place in 1 second, of 10 million cubic meters per second. So that's a lot of water. And we see some rocks like this one. This rock, if you look at the geology of this rock, it doesn't have anything to do with the geology of rocks that are surrounding. They're out here in this area. So this rock came from pretty far away. It was traveled on an ice raft. And this large pothole created by, you can see a person here at the top, created by water that was swirling around, that was associated, a giant whirlpool associated with this flood caused by the failure of that ice dam. And scabland channels cut by the floodwaters. Silt that was layered up in various places. So it was really quite an event. And giant ripples. So I know I'm getting into this in a little detail, but I want you to just sort of appreciate how significant some of these paleo lakes were and the failure of this one particular paleo lake. Here's a glacial, the shoreline of glacial Lake Missoula, where it was when it existed, the shoreline. There's a school there sort of at the base of the hill now. A couple of other paleo lakes, because some of these you've heard of. Lake Bonneville you may have heard of. Lake Bonneville is the large paleo lake that existed at the end of the Pleistocene that's today known as, the remnant is known as the Great Salt Lake. And here's Great Salt Lake right here. It's got two different colors to it. There's a causeway that runs through the middle of it that sort of separates water from the north and south. But just so you can appreciate how big Lake Bonneville was the paleo lake, or where all that meltwater ended up. And here's Great Salt Lake, just a remnant of this massive lake known as Lake Bonneville. There was another big lake in the western part of Nevada, you can see. And I'll show you an example of one other place here, Pyramid Lake, in just a moment. But here's the ancient shoreline of Lake Bonneville. So you can go there today and see this, and see evidence, fossil evidence, and other kinds of geologic evidence that this massive lake was here at one time. Pyramid Lake was the other one I was talking about, and from this lake that's in the far western part of the state of Nevada. So that's the remnant of a large lake as well. And here's some of the shorelines along the Pyramid Lake basin from that paleo lake that existed at one time. And then another lake that if you grew up in California, you probably heard of this. Maybe not people who have grown up or grew up in other places, but Mono Lake is a pretty famous lake in California. It's a paleo lake. It's kind of well known because the folks in Los Angeles built an aqueduct up into Northern California to sort of take the water. So there was quite a controversy and a lot of concern among environmentalists back in the 1970s and 1980s that the city of Los Angeles was sucking Mono Lake dry. And we'll go ahead and finish up there.